Okay, so we're going to start the year off with Unit 1, Learning Target 1, and we're going to talk about some properties of real numbers, okay? The good news about this is that all of the properties you are going to see, you already know them. You just may not know the actual name for them or the property name for them. So we're going to talk about 9 properties, and these properties are only going to apply to addition and multiplication, okay? So we're going to talk about the addition property and then the one that relates to it on multiplication end. So let's go back to first grade when you first learned how to add numbers. 5 plus 3 was 8. And then your teacher said, hey, what if I switch these two around? What if I said 3 plus 5? Do you think I'd still get 8? And hopefully you said yes. So we learned back in first grade that the order that you add these numbers in does not matter, okay? So the order does not matter, and I'm thinking that you remember the name of that property, and the name of that property is the commutative property. Property of addition, okay? Because there's also commutative property of multiplication. We'll talk about that one, okay? So the commutative property of addition says that the order does not matter. So in terms of algebra, take any two numbers, A and B, add them together, and you'll get the same sum as if you add B and A. Okay? You knew that. All right? Same rule applies. If I take a 3 and multiply it by a -7, I get -21, right? If I take that -7 and put it first, I'm still going to get -21. So just like this is called the commutative of addition, we're going to call this one the commutative property of multiplication, obviously. Okay, so the order that you multiply them together does not matter. And what that looks like in algebra means don't put an addition sign in between them. Obviously, you're doing multiplication. So if I multiply A times B and I multiply B times A, flip them around, you're going to get the same product. Ready to move on, okay? So those 2 of the 9 properties we're going to learn today. The next 2 properties, okay, we're going to kind of go corresponding here. And I think you know what this means. 2 plus 3 plus 4, okay? So you know by now, order of operations says that you have to do what's in the parentheses first. So if I do what's in the parentheses first, I get 5 plus 4, and I get an answer of 9, okay? Now, this next property says, okay, don't change the order, okay? 2, 3, 4, 2, 3, 4. This time, just change the grouping symbols. So instead of adding 2 plus 3 first, order of operations says I have to take that 2 and add it to this sum, but I still get the same answer, okay? So not switching around the order, we're switching around the grouping symbols, and that's not the commutative property, that's called the associative property. And this is the associative property of addition. Okay, the associative property of addition says take A plus B and add them together first, then add C, and you'll get the same sum as if you added A to the sum of B and C. Okay, that's your definition there. And the associative property also applies to multiplication. So if I took, instead of just adding 2 plus or times 3 times 4, and did the 2 times the 3 first and got a product of 6. 6 times 4 is 24. If I didn't change that order, I just changed the grouping symbols. I want you to think about the word associate. Associate. Who do you associate with? That means hang out, group with. So take the 2, multiply it this time by the 12, and you still see that you get your same answer. This is called the associative property of multiplication, okay? And that means that if I take the A and the B, take that product times C, I'll get the same answer if I multiply the product of the B and the C times the A, okay? Good? All right, so that's 4 properties. Let's learn the next 2. This is one I know you know, and you may have actually learned it in kindergarten, to believe it or not. Okay, if you were given a problem like this that said, I have a number 5, what do I need to add to that to keep it 5? Okay? So obviously, if you don't want that number to change, then you're going to put in a big 0. So you're looking at me thinking, why are you showing us this? We're in advanced algebra. We know this. Okay, do you know the name of the property, though, that this is called? Okay? So the name of this property, because you're adding, so we're going to call it the additive. And the next word is kind of easy to think about because the next word it's called the identity property. Okay, so the additive identity property, I want you to look at the word identity. 5 is 5, and it maintains its identity. So when you hear identity, I want you to think whatever you started with didn't change. That 5 stayed a 5. And so if it's addition, the additive identity property of addition is 0 because 0 does not change anything. Take any number, add 0 to it, you stay that number. Okay? And the multiplication also has an identity property. That would mean if I take 5, what would I multiply it by if I wanted it to stay 5? It's not 0. Okay, the additive identities for multiplication and addition are going to be different, obviously. So this time when you're in maybe 3rd grade and you learn your multiplication facts and your teacher says, okay, it's time to learn your ones, you are like, woohoo, ones are the easiest thing ever because it doesn't change. So maybe you didn't learn the name of the property in 3rd grade, but you knew that multiplying something by 1 didn't change it. So this is also an identity property, except it's not the additive property, it's the multiplicative. multiplicative. So this is the multiplicative identity property. Okay? And the multiplicative identity property says, take any number, multiply it by 1, and your answer will be that number. Okay? I really think of all 6 properties that we've learned so far out of the 9, you know these. You know the idea behind the property. Now you just got to remember a little bit of a word with it. We still have 3 to go. Okay? So let's continue on with our adding and multiplying. Okay. The 4th property that we're going to learn says, okay, I start with a number. What would I add to that number? This one's a little trickier, okay, to get that identity property 0 for additive, okay? So this might be tricky for somebody who doesn't know anything about the integers yet, because they may look at this and say, what do you mean? If I have to add something to 7, my sum is going to be bigger than 7, right? Not necessarily, and you may not have been introduced to the world of negatives until maybe, 5th or 6th grade. So you know by now, hopefully, that if you add a negative 7 to a positive 7, you will get a sum of 0. Just like if I started with a negative number, what would I have to add to a negative 10 to get a sum of 0? You would have to add a positive 10. You know that those are called opposites. You also know that a fancy name for opposites is inverse, right? Last year we solved equations using inverse operations, so it's kind of fitting that the word inverse needs to be in this property name. So we're going to call this adding, so it's additive. Additive. I can't talk and spell at the same time. And not inverse, or not the identity property, this is the inverse. So additive inverse property says, take any number, add the opposite of that number, and every single time without fail, you will get a sum of 0. Add 2 opposites, your sum is 0. You knew that. You canceled out tons of equations last year with this property. Okay, you may not have known that's what the name of it was. Okay, this next one is a little trickier, okay? So, and a couple kids every year get this. So you know the additive identity element is 0, multiplicative identity element is 1. And this stumps people whenever I ask them, what do you need to multiply 8 by to get 1? And before kids think, they just start shouting out answers. 1. No, 8 times 1 is 8. 0. No, 8 times 0 is 0. Negative 8. No, 8 times negative 8 is negative 64. Well, then what are your other choices? Okay, so if you remember back to fractions, when you had to multiply fractions, you know that if you had a number in the numerator and that same number in the denominator, that they canceled each other out, right? So to take 8, I would need to multiply it by its reciprocal, which is 1/8, to get 1, that additive or the multiplicative identity element there, okay? So maybe in like 6th and 7th grade we called it the reciprocal, so we're going to call it the multiplicative inverse. So that's just a fancy way to say reciprocal. Multiplicative inverse property, okay? And that says take any number, multiply it by its reciprocal, and you will get 1 every single time without fail. Okay? And there is one more property, and it's not necessarily specific to addition or multiplication. It actually involves both. You used this property a lot last year. It's called the distributive property. Okay? And the distributive property is unique because let's take a look at this. Let's take 2 times 3 plus 7. Okay? Order of operations tells you do what's in the parentheses first. So you're going to take that 2 and multiply it by 10 to get 20. And I do want to point something out real quick. I want to point out that I'm not adding like I was here. See how I have a plus sign in front of this parentheses? That means add. With no plus sign in front, you're not adding, you're multiplying. So this says that, okay? Another way to look at this would be to say, okay, I could find the sum first and then the product, or I could multiply each of these terms in here by the 2 and then add those products together. So you mean to tell me I could take the 2 and multiply it by the 3 and add that to the 2 multiplied by the 7, and would you get the same answer? Just like we did in all the other ones, a little different work. So 6 plus 14 is also 20, okay? And I want to point something out here. I want to point out that this 2 is kind of like your common factor, and there it is right there, okay? So you have your common factor of 2, that was multiplied by both the 3 plus the 7. So this is an example of what the distributive property looks like, okay? And you may have seen it like this last year. So you may have seen it like x plus 4, okay? Well, I know order of operations says you have to add what's in the parentheses first, but what if you can't? What if an algebra rule says that those aren't like terms, so I can't add them? You have no choice but to do the distributive property. If I were to just give you this problem and say do it one of the 2 ways, yeah, this way is easier. But sometimes that's not an option. So I know last year sometimes all you had to do, sometimes your teachers may have done this, and that's kind of a little shortcut, 5 times x, 5 times 4. And I'm not opposed to shortcuts as long as you understand the reason behind the shortcut. So some teachers may make you show this step instead. So 5x plus 20. Oh, that came from the 5 times the x added to the 5 times the 4. And that shows you how you get each of these terms. And there is your common factor of 5 in your original problem, okay? Distributive property is a classic example to use in perimeter. So if you have a perimeter problem, okay, so let's say this is length 5, this is 10 units, okay? There are 3 basic ways to kind of do this. Somebody who may not know or be, confident in their math, they may just say, okay, I'm just going to do 5 plus 10 plus 5 plus 10, because isn't that what my teacher told me? Add all the sides up, okay? So that's going to give you 30, right? Okay, so a little more advanced way of saying that doing it could be, well, if it's a rectangle, by definition, these 2 are going to be the same as those 2. So that means I have 2 of the 5 plus 10, right? That means I have 2 lengths of 15, which is going to also give me 30. Another way to look at it might be, somebody might say, okay, well, I have 2 5s and I have 2 10s. Right? So if you have 2 side lengths of 5 added to 2 side lengths of 10, if you look at it, it's just the distributive property. You're choosing to do it this way instead of this way. You're still going to have 10 plus 20, which is 30. So all three ways, these two ways are a little bit more advanced. So we have 9 properties, and it's kind of only like remembering 5 really, because 8 of them are in pairs, right? So you have the commutative, order doesn't matter. Associative, the grouping doesn't matter. The identity, to keep it itself, and the inverse. And then the distributive property is that 9th one. So I want you to kind of remember them in pairs, okay? So that's learning target 1, 1.